One of the best features of agent skills is progressive disclosure, which means that if you properly define and structure your agentic skills, you're gonna avoid wasting precious tokens and polluting the context window. So let me pick up this skill I just created to show you exactly how it works. First of all, a pattern I like is structuring the description into multiple lines and maybe even use something like what, when, or even how, so that it is simple for the language model to decide if this skill has to be loaded. In this example, I'm gonna validate the syntax of an invented language. Here I've got first of all the template. AI works great at using templates, so if you provide how the answer should be structured, they most likely gonna respect it. But the magic trick is basically splitting the rest of the skill into multiple files. And this is the first baby step to see how progressive disclosure works. Now, let me try a super quick example. Is this valid in foo? And I type, for example, declare 1, 2, 3. So that here you can immediately see how Copilot works in reading the skill. First of all, it found that there is in fact a skill, and this is what it's gonna use. Now, the skill uses the word declare, and here, let me go back, I mentioned that if the text contains the word declare, then the model has to also load this file. And that's exactly what happens. It found out that there is a declare, and only for this reason, it actually read the other declaration file. Now, the declaration file says that the first character cannot be a number, and so this is the answer. This is invalid, and that's exactly the reason. Now, one thing you notice is that it followed the template. Hello, these are your hints. And the other thing, as I said, is that it loaded the declaration file, but not all the other files. Oh, by the way, if you found this kind of videos helpful, just don't forget to subscribe. If I try one more complicated example, is this valid in foo? And I type hello. Now, this is an array, so here, if there are some square brackets, it's gonna load the array file, and the array file is, well, first of all, has the definitions of what's valid and what's not. And here, there's also the reference of a nested array file. But if you look at the file that the agent read, you're gonna notice that, well, first of all, it found that there is a skill, then the skill mentioned array.md, but this already contains the answer, so it didn't need to read nested array. Well, if you try nested array this time, hello world, what I'm gonna expect is that this time the LLM is gonna, well, again, first of all, read the skill, then read that there is an array.md file, and lastly, it's gonna find that array.md needs the nested array. Now, it only did nested array because this was exactly the same chat instance, but if I create a new one, and again, I ask, it is valid in foo, now you're gonna see the full process once again. First of all, the skill, then the array file, and only lastly, the nested array file. And one thing that's also interesting while it works is that you can see that into the debug view. You can find that the first time it read a file that is exactly my skill.md, the second time it read another file that is array.md, the first 100 lines, and this is the content, and the third time it read the third file that is my nested array. And you can also see that here, obviously. But now the final example. As you can see here, there's a script folder with a simple script. And the cool thing is that in my skill definition, I said when there is a function call, you read the function call file as the other two. And the function call file also says, well, those are the rules, but let's say there is some more complicated logic that needs a script to actually validate the answer. And that's exactly what's going to happen. For example, is this valid in foo? And the function is foobar, 2 asterisks, and 1, 2, 3. Let's see what's going to happen. Now, once again, I'm going to expect that first of all, it's going to use the skill. Now the skill contains the text about function calls. So it's going to read probably, well, there's the call keyword. So it's going to use function call. But function call says that there is a script. So the agent understood that, well, there is a script to run, and it's gonna prompt me if I want to run the script. So as we planned, the model ran the script and found the answer. You can also see that in the hidden terminal, now it's no longer hidden, that The agent tried to use the script answered with, no, that's not a valid function name, and this information has been injected into the context so that the model could answer me with, well, the right answer. This works great, but beware when you download skills from online repositories and stuff. If they have a lot of scripts, and some have a lot of scripts, be careful, because you're just downloading some instruction for your language models with some scripts, and if you do not review them, that's kind of a huge security breach, right? And with that said, I hope you found this video interesting. As always, please don't forget to subscribe so that you're supporting my channel, and also you're gonna get informed when there's a new video similar to this one on GitHub Copilot. Thanks again for watching, and see you in the next one. Bye!